welcome, ladies and gentlemen, to the Subscribe blog. And if you haven't been on it yet, well, now you are. I'm driving on the Autobahn. This is the A61, so the mighty German Autobahn. And I thought I'd take you on a ride because today's topic is about telematics in this device to cloud series. So that's kind of the first one that I'm doing outside the studio and on the road. And the reason why I'm doing it in this car is that kind of right behind me here sits a little Raspberry Pi that's actually taking eager notes of what I'm doing here, of how fast and how slow I'm driving. I'm currently going at a fairly normal cruise speed here, and that's 160 kilometers per hour. So that is about 100 miles per hour for you watching in America, and it's not necessarily crazy speed. There's traffic right behind me here, and it's a little Opel super compact car, and so the normal cruising speed here on this stretch, which actually doesn't have any limits, is about between 80 and 100 miles per hour that everybody's going. So that little Raspberry Pi that I have behind me, which I'm going to show you later in this episode, runs a Raspbian. That's a version of the Debian Linux distribution, and runs an application that is a variant of a popular OBD logger application. OBD stands for Onboard Diagnostics. There's an Onboard Diagnostics standard, OBD2 to be precise, and that is in every modern car. In America, cars were required to have this since 1997, and really every modern car today has this port. And for me, this port sits right under, on the left side, under the steering wheel. And I have a little adapter with a so-called ELM327 chip that plugs into that, and that translates the CAN bus signals into signals that are intelligible, that you can go and figure out with a standard terminal application. So it's kind of a mapping between the CAN bus data structures to something you can read out very easily with an RS-232 serial port. I just hit the speed limit zone, so from here on where I'm going, I'll be mostly under speed limit, so that was the only fun part here for the stretch that I'm driving. I'm driving to a conference, by the way, in Mannheim, so I have like 270 kilometers ahead of me. So this is what this, as you know, the navigation system, so what the navigation system tells me. And one interesting thing, because I want to talk about telematics more broadly and then show you the Pi, but I'm not going to show you code today. We're actually going to do that in some of the next episodes, is to talk about some scenarios in the car. And actually being on the road here and driving is a really good example for what's happening, what you can do. So I'll show you just a few things that I didn't invent, that we didn't invent, but just to show you some examples of what you can do with modern technology in the vehicles and what I have right here in my Audi. So I have put in my destination of where I want to go, but there's also voice control, so I can go and control this all through voice. That's interesting. But what's also interesting, so I'm not going to show that to you because of course that's going to fail when I'm here on camera. And it's also speaking German, so it's not going to help you much. But there's an information thing here, so I have this central control thing where I have my hand, and so I can go here, and here's my my data. So now the lady's actually telling me that there's a traffic jam ahead of me. So here's some traffic information that's being sent to me, and that's sent to me in one of two ways. First of all, the radio signal here in Germany, and of course in very many other places, the public radio signals and also the private radio signals carry this traffic information. So traffic information is being broadcast to the vehicles on that route. What you might also notice is that I'm online here. So this says online, What this means is that this car here is actually equipped with a SIM, and that SIM sits down here. You can't quite see that; it's just below the frame of the picture. And so this vehicle is actually online at all times, and it has access to a special pool of data that it's getting information from. So I'm actually getting more traffic information than what's coming over the radio. It's a more reactive, it's a more current set of traffic information. And in fact, I can avoid a lot of traffic jams way before everybody else does. So sometimes the lady here in this vehicle will send me off the Autobahn or a different route without me even having any direct idea why she does that, but I usually follow her because she knows better than I do, because she gets more information. And then also, obviously, that also gets displayed here. Another feature that I have here, and that's because I'm online, is I have the Connect services here of Audi. So it's now requesting, because I have a 3D connection, it's now requesting information, and the overview that I'm getting here now kind of gives me weather and the price of gas and travel information and city events and current news. So I can go and push on current news, and I will get a digest kind of the news of the day. So if I'm on the road quite a bit, then I get at least the headlines here that I can go and watch. But the floating car data is something that's certainly interesting. What I have in the Raspberry Pi in the back, which I'm going to show you a little later, is information that I pull out through the diagnostics port, and I can get the RPMs, and I can get the speed, I can get a lot of data out of this that I can then send into the cloud and evaluate myself. And that's something that obviously customers in the commercial space are doing for a range of scenarios. So I'll get to that as I show you the Pi. So this here is the Raspberry Pi I have in the vehicle. It's wired up to the diagnostics port through this black cable. We're going to take a look at the diagnostics port in a second, and then that white cable goes here to my cigarette lighter, or as I should say, power port, because I don't smoke. And so the Pi sits here. Usually it's a little bit better tucked away with the SD card sticking out. And when the car goes on, then the Pi turns on, kind of auto boots into the app that we're going to take a look at in the next episode, and then start sending telemetry data out of the car using the Wi-Fi hub. Here, up here, and it's very dark, is this thing, which is this OBD piece. You can buy those things for about 15 bucks, and it has an Elm 327 chip, as I said, and that is that little bridge between the CAN bus that this plugs into. That's the OBD interface that sits down here in the Audi, and then I can talk to that thing using USB, and so that's the translation for that. And now we're gonna go and take a quick look at how this turns out in Excel. And as promised, I take you into Excel. What you see here is a section of a drive that I took about a week ago. And so I just grabbed some arbitrary data out of my data pool that I have. What you see is the partition key. The partition key indicates that this is out of the table store. And this identifies a drive. The way the application works is the Raspberry Pi pushes data into Service Bus using the AMQP protocol. The AMQP protocol is suitable for this because, first of all, it maintains a TCP connection, which means I can also send data back into the car if I wanted to very easily without having that car specifically addressable. But also, the nice thing about AMQP is that it is a reliable handoff protocol, so there's never any doubt whether the data was sent or not sent and understood by the receiving party, which is important for scenarios like here where the connection might drop out at any second because we're going over wireless. So that is, as a model, superior to what you would do over HTTP, where there might be doubt. So AMQP is a very suitable protocol for that kind of a scenario. We'll also see this is the row key. That is when the record was actually generated. So you can see I generate a record every second, but I'm only sending it. This is the send time when the record was received. I'm only sending them about every minute, which means I'm packing these records into a batch. And if I go and scroll down, you're going to find here's the 158. I'm sending these records about every minute from the car down, and until then I kind of aggregate them in the vehicle. Then there's the epoch timestamp of Unix, and then here's the measurements that I'm taking: temperature and the RPMs of the engine, the speed, and then an airflow parameter. Here's this all plotted up for this segment that I was driving. This is the RPMs. And this was between 14:56 to roughly shortly before 3 p.m. in the afternoon in local time. While I was driving, this is the RPMs. You can see this is a diesel that is very happy at 2,000 RPMs on average. Here I was driving like strict 120, which you're going to see also as I go and scroll down. And then there's another graph here. So the temperature, the engine temperature, or cooling in temperature, 88 degrees by average, going up and down a little bit, not too much as I drive. And this is the graph you probably be waiting for if you know that I'm on the Autobahn. As you can see, I haven't been going too crazy. 160 is exactly 100 miles an hour. 140 is about maybe about 80. I've been going here, normal cruising speed, which I would call it. Hit a construction site, what you can see here. So through the construction site, the speed limit is 80, and then there was a bit where I could go again a little bit quicker, and then I had to slow down again, and then you can see there's a stretch here where I had to go cruise control. So there was a speed limit area with some construction site in the middle. So you can see there's a lot of construction going on where you have to kind of slow down to between 80 and sometimes 100. And I hope that the police is not watching this video. All right, so that much of as an intro to the scenario, the telemetry scenario, telematic scenario, if you will, from the car. And in the next episode, I'm going to kind of open the lid on this and show you how I'm doing this on the Pi, on Linux, for sending the data, and also on Windows Azure for capturing that data and putting it into the table store. We'll go and walk you through, of course, that code. Until then, thank you for watching this episode, and bye-bye.